All right, welcome back, guys. So we're going to be looking at matrices in this section, and you've already had a little taste of matrices. Namely, I showed you how to use them to solve those systems of equations. And matrices are really powerful, guys. In fact, I put a little video here for you to watch. It should be in Blackboard. Just kind of an introduction of matrices and how they can be used. They're really good in storing or representing data. Okay, if you remember that system of equations that we had, we came up with that one matrix A, and it represented the coefficients of that system. Okay. And then we had that second matrix B that represented the constants. Well, having those two matrices defined that system. We could then forget about the variables, okay, the X, Y, and Z. So matrices are extremely useful, and we're going to look at them in a little more detail in this section. All right, so what is a matrix? There's a little allusion in this video to the movie, okay? But a matrix, guys, is very simply a rectangular array of numbers, okay? It doesn't even necessarily have to be numbers. It can even, there can actually even be algebraic expressions in here, okay? But a matrix is singular, and then matrices would be the plural, okay? And here's an example, okay? And we've discussed this previously, but this matrix, it's rectangular. It's comprised, as you can see, of 3 rows, and it's got 2 columns. And then these are the entries, okay? These are called the entries. And interestingly, we can perform matrices. You guys have already done this if you solve some of those systems of linear equations using matrices. And every matrix will have an order, okay? So the order is like the dimension of the matrix. It's going to be the number of rows by columns, okay? So this matrix right here, for example, is a 3 by 2 matrix, and this is the way you would write it, okay, because it has 3 rows and 2 columns. All right. And we can perform some matrix arithmetic. So just like, we can perform arithmetic with real numbers, so too we can with matrices. And a lot of those properties that work with real numbers, like commutativity, meaning in other words, you can add 2 numbers and the order doesn't matter. That works with matrices as well. So a lot of those same properties we see with matrices, but there are some properties that apply to real numbers that don't actually apply to matrices. So for example, commutativity with multiplication. The order doesn't matter in multiplication when you're multiplying 2 real numbers, but the order matters with matrices, okay? But anyway, all right, so let's look at how to do some matrix addition and subtraction. And, again, we'll look at how we can do this in the calculator as well. So let's say we're given 2 m by n matrices, okay? So this just means 2 arbitrary matrices such that, and they have m rows and n columns, okay? They have to have the same order, guys, in order for us to be able to add or subtract them. This is the way addition and subtraction is defined for matrices. And also, if you recall, we like to utilize capital letters in referencing a matrix. So this is like matrix A plus matrix B. So how do we add those two? Well, what this is telling you right here is that basically you're going to take each corresponding entry, okay? So like from the first row, first column, plus the entry from the first row, first column of your second matrix. That's how you do it, okay? So corresponding entries, that's what this means right here. Now, we won't get into these subscripts. And the same thing for subtraction, okay? So if I had a matrix or two matrices and they were both 3 by 2 matrices, then I would just start subtracting the entry, an entry from my first matrix minus that same corresponding entry in my second matrix, okay? And that'll become the new entry in my resultant matrix. We're going to see this illustrated down here. All right. So, and like I said, let me just reiterate, only matrices with the same order, okay, can be added and subtracted or subtracted. Matrices, guys, they're used a lot in physics. They're used to identify like the position of an object, the position of a particle. They're used to represent things called vectors in physics, okay? So you may have heard of those before. They're used a lot in computer graphics or any sort of graphics. They can represent the position of a pixel, and furthermore they can represent like the color and the intensity of that pixel. Okay, so a lot of the behind the scenes math involved in the images that you see on any sort of screen, they don't have to be moving, any sort of screen. They involve matrices, matrix arithmetic, okay? So anyway, all right, well, let's look at example 1 right here. We've got matrix A, and let's go ahead and identify its order. It is a 3 by 2, okay, because it's got 3 rows and 2 columns. And then B is also a 3 by 2 matrix. And so it says find the sum and difference of the two matrices. Alright, so we'll do this by hand, and then I'll show you we can do it in the calculator as well. So A plus B, so that means you're going to take matrix A, and I'll just rewrite it real quick. And you're going to add to it matrix B with all of its respective entries. Okay, and you're going to get another matrix that's going to have the same exact order. Okay, because to add these two, you're going to add the corresponding entries. So for example, first row, first column, 1 plus first row, first column here, we've got a -1. So 1 plus -1 is 0. That's actually what this is telling you up here. The I and the J, these represent the rows and columns, okay? And then first row, second column, we've got a 3 plus this corresponding -2, and that will give us a 1. Then we move to the second row, we've got -1 plus 1, we get another 0, don't we? And then we've got a 5 plus a -2, which will be 3. And then 6 plus -3 in the third row will give us a 3. And finally, third row, second column, 0 plus 1 is 1. Okay? So this is the sum of those two matrices. Now we'll do the difference, and then we'll do this in the calculator and check. Okay, so yeah, let me just copy these down again real quick. Right now we're going to be subtracting. Now you've got to be a little careful with the subtraction, guys, because remember, anytime you're subtracting a negative, that's the same as adding a positive. Okay? But And we're still going to get a 3 by 2 matrix. Alright, so 1 minus negative 1. Well, that's the same as 1 plus 1, which is 2. 3 minus negative 2. That's the same as 3 plus 2, and that's 5. And then we got negative 1 minus 1. That'll be negative 2. 5 minus negative 2, same as 5 plus 2, which is 7. 6 minus negative 3, that's going to be 9. And check these in your calculator if you need to. And then 0 minus 1, that will be negative 1. Okay? So those are our two results. Now, let's look at how to do this using the calculator. Guys, this first part 1 video may not be real long. I'm pretty exhausted. It's the end of a long day for me. I was working my side job today, and I had a lot of yards that I had to take care of. Kind of wore me out. All right, so if you recall, we're going to hit second, this key right here to access the matrices, but to actually input the values for the two matrices that we're going to be working with, we're going to come over here to edit, hit enter, and then type in the dimensions. Well, these are not 3 by 3. This is a 3 by 2. Well, the 3 is okay, but I need to change the number of columns to 2. And now I'll input these entries. 1, 3, negative 1, 5, 6, and 0. And then I'll go back to my matrix screen, go back to edit again, but go down to number 2 for B. And it is a 3 by 2 as well. That's why I like showing you how to solve those systems of equations using matrices, so that hopefully now you're already familiar with how to input them. So negative 1, negative 2, 1, negative 2, negative 3, and finally 1. Okay. Now remember, we need to quit this screen, so we're going to hit second mode. And now we need to tell the calculator to do exactly this. Add A and B together. Okay. So we go back to our matrix screen. We stay right here. We just select A. We hit the plus sign. We go back and we select B and hit the plus. Well, let's not hit the plus sign again. Let's hit the enter key. Okay. And there we go. Let's compare this. It matches, doesn't it? That's what we got. Okay. Now let me show you a trick. You could, if you want to find the difference, A minus B, you can go back and put A and then minus B. Or you can do this. Since A and B are already in there, you can hit second and then the enter key. And it will repeat that last entry. And you can just scroll over here and replace that plus sign with a minus. So it'll save you a little bit of work. And then hit enter. Now let's compare this with what we obtained earlier. And I'm checking, and it matches. Okay. So the arithmetic, the addition and the subtraction, pretty straightforward. All right. I think what we will do is stop after talking about this scalar multiplication, because like I said, I'm pretty tired. My throat is kind of parched. Okay, so scalar multiplication. So what does that mean? A scalar, guys, it's a number that scales the matrix. Let me give you an example here. So remember how I said matrices can be used to represent objects? Well, let's say we got this x-axis, we got this y-axis. Okay, and I'll label this a little bit. So let's say we've got some object and it's sitting about right here. Okay, so what are its coordinates? Well, its x-coordinate is 1, 2, 3, 4, 5, 6, and then its y-coordinate is 4. Okay, so we could give it, or we could express its location as in ordered pairs, 6, 4. But you can also express its location using the matrix 6 and 4, okay, where the first entry is the value for x and the second entry is the value for y. And this is actually what we saw when we solved those systems of equations using matrices. Okay, you'd have a value sitting in place of x, a value for y, and then a value for z. This right here, this matrix, it expresses the position of this object. It is known as a vector, okay, in physics. Okay. And what we can do is we can scale the position. This would be called a position vector. Okay. We can scale its position. What does that mean? Well, what does it mean to scale something, or to scale up or scale down? It means to make it bigger, proportionately bigger, though. Okay. So what if I wanted this object right here to be twice as far from the origin as it currently is? Well, I can multiply both of its coordinates, its x and its y position, by 2. Okay. And when you do that, I'll write it like this. When you do that, you are multiplying it by a scalar. That's what that's called. Okay. So a scalar is just a real number. And a scalar, guys, can be a positive number, it can be a negative number. Okay, but basically what you do when you multiply a matrix by a scalar is you just multiply every single entry. Okay. So if I want this object right here to be twice as far away from the origin as it is originally, then I've got to multiply both of its position coordinates, right? The 6 and the 4 to do that. All right. And so usually you'll see it like this. K represents your scalar times, and then A is your matrix. Okay. So to multiply a matrix by a scalar, it's also called finding what's called the scalar product. Remember that word, product refers to multiplication. To find the scalar product, you're just multiplying the matrix by the scalar. All right, so let's look at one here. Let's do example 2. I'm going to zoom in. All right, so it says find 3 times A, where A is this matrix right here. So 3 in this case is our scalar. And this matrix is a 2 by 2. This is actually what we refer to as a square matrix. And it's called a square matrix because the number of rows is equal to the number of columns, similar to a square, in which the 2 dimensions are equal, right? All right, well, 3 times A means 3 times matrix A. Okay, and you literally, it's sort of like using the distributive property. You distribute this 3 to all these entries. Okay, and so if we do that, the order of our matrix is not going to change. It's going to remain a 2 by 2. But all 4 of these entries are going to increase by magnitude of 3. So this will become negative 9. 3 times 0 is 0. 3 times 4 is 12. 3 times 5 is 15. Okay? And you do the same thing if this were a negative 3. It doesn't matter. If you want to do this in your calculator, I'll show you real quick. Go to the matrix key. Guys, I'm going to go over here to edit. I'm going to let this one actually be matrix C. Okay, and it's a 2 by 2. And the entries are -3, 0, 4, and 5. Okay, so now I'm going to quit this screen. And now since I'm using C in my calculator, I need to say 3. And I don't even have to hit the times key. I just need to grab my matrix. And it is C that I'm using. Okay, if you hit enter, you'll get it. See that? All these entries match. Alright, so use your calculator if you want to. We're going to, in the part 2 video, we're going to look at how we can use matrices to represent data or tables like this. And we can perform some operations with them, and that can be meaningful, okay? That can have a significance in the context of this problem right here. So we'll see that in the part 2 video. Alright, so I'll see you then.